My name is Tolga. I will look at this linear regression homework. Uh, this cell for import some from library, and here we are load the data X train and Y train. X train is meaning population of a city. Y train is profit according to that population in that city. Uh, we running this cell, and here we will look at the type of X train and first five elements. Type of X-train is numpy array, and these are first five elements. This means 10,000 times. For example, this is 61,000 population in that city. And in here, we are looking type of Y-train and first five elements again. And Y-train is meaning profit in that city. For example, this meanings that much money. Now here we will look at the shape of X-train and Y-train and number of training example. This meaning we have how many data variables. X-train shape is like this. It's meaning one dimensional, and we have 97 data point. And here we are um, look at our data visualization. This scatter and title, we are looking this visualization our data set. For example, population of that city is meaning profit. Now we will do reflection on linear regression. Uh, this function is our predict function. Uh, these are W and P are parameters. X is our feature. For example, X is population of that city, and this function is meanings profit of that city according to population. Here, compute cost function, we will compute an exercise 1. We will compute cost according to these functions. Uh, total cost function is here, and each variable cost function here, and these are our predict function. M is number of training examples, and total cost is starting with 0, and I will post sum for each data variable. First of all, we are starting in this function, and this sign is meaning e equals to 0 until m minus 1. So we have 97 data, and we have two iteration for each one. So we will for iteration until m, and here we will write this predict function. For example, I will f v function equals to uh, these parameters w and times x, uh, this iterator plus b. These are regression function, and we will cost function. It's f minus y and square this this cost function, and I will write like that minus and square of this. After that, we we are compute cost for all data, and we will take this parameter equals to cost sum plus cost. Here, this for iteration until this part, and we compute for the total cost. We have to times 1 divided by 2m. So after that, for total cost equals to 1 divided by 2m times cost. So, and this function return total cost. And here initial w and initial b parameters is cell for uh, check this function. We have to look like this. Yes, post at initial w zeros like that, and gradient discount. We will gradient repeat until update for optimum results. These parameters. This alpha is means learning rate, and we will b minus alpha times derivative of b according to b cost function. For w parameter, we again learning rate times derivative of w according to cost function, and these are our functions for derivative. In exercise 2, we will compute gradient. These are derivative of w, derivative of b, and here are functions. For example, derivative b is predict function minus y. I will write this first of all. And here again, we have to write in for iteration, for loop. I'm starting for e in range. First of all, I have to write our regression function again. Now I have to write um, derivative of b according to cost function. These meanings are this function, our model function minus y. I will write like that. And I will look at w parameters. This function minus y times x feature. I will write like this. X feature. Yes, like this. And after that, for each iteration in for loop, I have to compute these parameters, pg and equals to, and we write here like this function. We have to times 1 divided by m for the total gradient update from all the examples. And we have to write here equals minus m. And I'm running this cell. Here, compute according these zero values, and I will have to like these numbers. Yes, all test posted. V, W, and P parameters like this. And again, compute and display cost and gradient with non-zero. We again result is the same expected output. And learning parameters using batch gradient descent. Now here uh, for iteration after how much iteration we have to compute the cost function, and we will take this list, and according to discount function our cost is have to our cost should be decreased. Now we will try these iteration numbers, and our learning rate is this, and I will running this cell. Our cost it will decrease in time, and our parameters w and p found by gradient descent like these numbers, so it's same the expected output. Here m equals to x train shape is meanings m is 97, and we are created a numpy array with zeros. mm, 97 zeros predicted. Predicted has 97 zeros, and this for loop we will predict our x train and this w and p parameters we found it here. These parameters we will predict, and we will write each zeros according to here. So I'm running this cell, and here again we are visualization is our predicted function, and according to extreme variables. Yes, this line is our predict function. So our final values of W and P can also be used to make prediction on profits. So 35,000 people can be 3.5, our parameters is read already. Predict 1 is for mm, 35,000 people, and predict 2 for 70,000 people. Our predicted is like that, and are same the expected output. Thank you for listening.